Hopefully it's visible now.
Yep, I can see.
So I have just merged main into my branch, so it should be up to date. And hello, Blaze. Hello, hello. Can you hear me?
There we go. Sorry, my Bluetooth was reconnected. Good morning.
Great. Looks like everything's recording. Good morning. So, is there anything you would like to look at? I mean, all of you.
I'm happy to pick up wherever we left off last week. Myself, but then again, maybe Adam, do you have questions for any particular?
No, I'm just mostly here to watch and observe, and if I have questions, don't worry, I will happily speak up.
Alrighty. So,
I know William's on his way too.
what? Excuse me?
William said he was coming too,
Hmm.
but I don't know. He might be running a little late.
Well, I'm sure
So,
I'll have questions. So, what I was thinking about a bit was those look aheads. I think we have
uh-huh.
them hidden in here. Oh no, we have them here, but we don't generate them for the documentation or for the snippets here currently, and unfortunately they are necessary because of these argument parsing rules. I don't know if you remember those.
Yes, vaguely. I remember there was an issue with a positive and a negative look ahead.
Right.
Uh,
So the way these are defined, so this slash no default, is that there's some kind of parameter specification, and then after it we can have either a comma or and the argument list. Right, so this would be in a function definition in here. Right?
right.
And that's all for all the different parameter types. The problem is that the ending parentheses is not matched by this rule itself.
Oh.
Right, so the slash no default goes in somewhere here. That's parameters, and that's params here. Right?
Oh. So that ending parenthesis isn't the one that ends the param clip?
Right. So this just checks that the params are ended,
Oh, I see.
and that's it. Right.
Oh.
So it's not actually matched. It's matched up here. I guess theoretically we could make it match here, but the problem then is I don't think we could have the star etc here at the end or anything after the slash no default. Right, so if this would match the ending parentheses, we couldn't have any of that after it. So I guess this is the best solution for parameters. And when we run the script I've been writing, which ignores these lookaheads, these two rules get collapsed into one, and the comma becomes optional. Right?
Yeah.
So that's what we get here, which is of course
Okay.
very incorrect. So we do
Can we
need
escape
we
them
do
now?
need lookheads. So let's see if we can add them to the script. I don't know, maybe we should explain this some more. I don't know if I think we've started but left off somewhere. So please ask questions if anything's not making sense. But the gist is, the way this works is the grammar as it's parsed by the peg parser that already exists in Python is then converted to my little set of data classes, so it's easier to work with. And the thing that does the converting is this big match statement. Basically takes one thing and converts it into that data class. And for positive and negative look ahead, it returns empty currently. Right? Does that make sense?
And the peg generator runs after the AST is created. Is that right? Is it reading it from?
So the peg, this is the parser generator, right? So this is what processes the Python grammar.
Oh.
This thing, and
Okay.
it writes the C and header files and Python files and whatever based on this, right? So it parses this and gives me an AST of the actual grammar itself.
Oh, I see. Okay.
I take that AST, that's the grammar nodes here, and convert it
Mhm,
to
mhm.
my own AST, which
Okay.
is like usually easy. I guess there's repeat one, gives me one or more, and then converts whatever's inside. There's repeat or more, there's 0 or more, and so on and so on. So I guess what I do here is for positive look ahead and negative look ahead, which currently return empty, and empty is an empty sequence. So I will put my own positive look ahead, and hopefully the positive look ahead in the Python grammar, which where is it? I guess it's in grammar.py. So it has a node inside, so I convert that. I needed to check because they're named differently for each one. I also looked at negative look ahead, which should work the same. We should probably include the cut as well later, just because it's very small and it would make the grammar more correct. There's too many symbols anyway, so people have to learn when using this. Right, so what this gives me is, of course, name negative look ahead is not defined, so I need to define it, and it would be one of these. That's what I call decorator, which is an AST node that has exactly one child. So it would look very similar to this 0 or more, right? So this would be negative look ahead. The precedence. That's interesting. The precedence of this negative look ahead. Let's see what kind of precedences we have. Somewhere here. Oh, here it is. Choice sequence repeat atom. I guess it should be close to the repeat. But I'm not really sure on which side. Let's try this one and maybe make it better later. So look ahead, and how would negative look ahead? How should negative look ahead be represented? The same way as in the Python grammar, which is with a exclamation mark. So exclamation mark plus whatever's inside, and the same thing for positive look ahead. And that should be prefixed with an ampersand symbol. Right. I hope you're following, and this gives us a very big
yeah, this is
diff.
actually beginning to start to make sense to me.
Right.
So, yeah.
So this is getting us a very big diff with all of these look aheads added. And I would like to get rid of some of them. Well, here's one that's pretty good. That one's actually meaningful. But here we have a look ahead for def, an at, and an async, and I would assume that function def can start with exactly these three kinds of symbols. So this look ahead is not useful, right? But how do I get rid of it? That's the question. And I'm not exactly sure, but I can try something. I'll put this in Git so I have something to return to. So how would I get rid of that refresh of this? If I know a function definition can start with decorators, which always start with the at, or it can start with async, or it can start with def, right? So I guess I would need to look at this look ahead. And if I look at all of the look aheads we have, their choice with individual tokens inside, right? So there's a choice of tokens. There's nothing really complicated in these look aheads that appear in Python's grammar, right? Let's see all of the look aheads here. And tokens, single token, choice of several tokens, and so on.
Do we have a gather for look ahead?
So what I would do is...
Oh, you do. It's T look ahead.
Excuse me?
Oh, I thought I saw one that said T look ahead.
And T look ahead is again just a choice of a few.
Oh, that's okay. Sorry, that's
tokens. Where's T primary documented here? Refresh. Yeah, that's a negative look ahead. But for now, I would like to get rid of this one. Let's see. So to get rid of this look ahead, I need to figure out what the following thing can start with, right? And if it can only start with these tokens, then this look ahead is then this look ahead can be removed, right? So I guess I can only do this in sequences. Let's see, here's a sequence, and the sequence has a pretty complicated simplify function already, but the main part here is the simplify subsequence, which gets called for each of the subsequences. So it gets called for the whole thing, and then for everything from the first item and so on. Well, if this was actually a sequence, it's not. But so for this, the simplify subsequence would get called for both, and then just for function def. So what I want to do is I want to look at the first two things in the subsequence and check if the first one is look ahead, or positive look ahead. And the positives look ahead's item should be either a choice or could either be a choice of the tokens or a single token. So either choice or token. Right?
Yeah.
So this would be the look at contents, and then the second thing in the subsequence would be sorry, choice and token need this, and the second item would be basically anything, right? So this is the case I'll be looking for. Does that make sense?
Yes.
So if this look ahead is a choice, then I want to get everything from inside that choice, basically, which is look ahead dot what's it called? Haven't been doing this for a long time. Items. Look ahead dot items. Okay. Right? And I want all of them to be tokens only.
Okay.
Right.
So the talk is that's the name and
for each
okay.
token. Tokens. I check if it is a token, and if not all of them are tokens, then I do nothing. Right?
Yep.
Can't
Yeah.
simplify that yet. Right?
Yeah.
And if I just have a single token here, then my tokens will be a list with that single token. I named it look ahead. Right?
Right.
Okay.
Right.
So now I have the tokens in the look ahead, and I want to see what am I looking at here? I know this. I need to know that function def can start with some tokens, and here I need a superset of the ones that function def starts with, right? If this is a superset of that, then I can get rid of this. Does that make sense?
Yes.
Right.
Do we need to call it superset something?
Excuse me?
Do we need to give it a name? No, I guess not.
Well, these are the tokens right now.
Yeah. Okay, we don't. Okay.
And I'm talking about sets, so let me convert this to sets. So if the tokens is a superset of next node's start tokens, there's probably better name somewhere. So all the tokens that this can start with, then I say that the look ahead is redundant. And I return nothing and 1. So what this returns is some kind of replacement, and then it says how many items from the subsequence it processed. Right, so this says it should replace the first item in the sequence, which is the look ahead, with an empty empty list. Right, the default when there's no simplification to be none, processes one item and gives it back. Right, so this should work, but the big problem here is that we need to implement these start tokens. And I guess if you have some experience with formal grammars, is such a thing as a start set. I think I remember from school. Let's see what the terminology says. I no longer have access to all my textbooks.
Yeah, I don't either. We did a lot of this in linguistics.
There's a start symbol. Compiler construction. It's probably somewhere deep in here.
Ooh, production rule.
It's one of the more complicated grammars. So let's be descriptive. Let's name it possible start tokens, right?
Okay, sure.
So this will be the set of tokens that this node can start with. And what we need to do now is implement it for all of our AST nodes, right? So this
Yeah.
says we don't have it implemented for non-terminal. Let's do test-driven development here. And a non-terminal is well, basically a token, I guess. When does non-terminal appear? I can. Oh, it's not a token. Oh, no, non-terminal is the name of a rule. Right, so it would be something like this function def.
Oh, okay. Oh, I see, because it's followed by other things.
No, it's this literal thing, like the name function.
Oh,
def,
it-
right.
oh, okay,
That's
this-
a non-terminal. This is a token, and this is a
That's
non-terminal. Which means, which is a bit complicated, because now, to simplify things, I basically need access to the whole grammar, right? Because what this can start with depends on some other rule. Does that make sense?
Yes.
So this is a reference to some other rule. And I don't think my AST nodes really have a reference to the grammar they're part of.
They don't.
No, they don't. So the way
Okay.
way we do things currently is the simplify rule set function will call. We'll go inlining rules, and it'll call this inlined method, which replaces all the references with the given replacement. Right? Does that make sense?
I think so. Probably, yeah.
Right.
In the sense that I'm not completely baffled yet, but yeah.
And I don't know if it's making sense for the other people who haven't been here for so long, but well, hopefully it's interesting.
It's definitely interesting. I'm just mostly watching and learning.
It makes
Yeah,
sense.
so basically the workflow is like this kind of grand loop where we look for things that might be duplicated. We figure out whether they have something in common with each other, and then we add a condition within this bigger simplification method, and then we try to
so
figure
this
out.
is inlining rules, right? So we take something like where did we have this? Under parameters, like this parameters here, and instead of that we put in the whole thing here, right? So if I look back at the function definition, we have this function def, and it has parameters directly, and parameters are expanded then. So this params rule is entirely skipped. I'm not sure
The
why
first
it's
one,
here, but
Yeah.
yeah. So this is inlined in the function definition. Right, so instead of params it says parameters now. And yeah, the way that works is we look through the whole grammar, and if we find a non-terminal, so the reference to another rule, we basically count all of them, and everything that only appears once in the whole grammar is then inlined. Because if something appears at more places, like this decorators, oh, I was looking at the wrong place, sorry. So apparently this probably appears in more places, and both link to this definition. I mean, here we could probably inline it as well because it's quite easy. But the current rule is to inline everything that only appears once in the grammar. That's a neat idea. Maybe we should inline everything that's smaller than the actual name for it. For example, this funk name. Anyway, back to here. So inlining calls some function with a replacement. Now simplification, to simplify what we had here, this look ahead, we basically need the simplification routines to have access to the full grammar. Which is a bit tricky, but I guess it's nothing we can't do. So every simplification function will get a grammar argument. I think I call it rule set. Rules. And let's add it. Simplify item. We'll probably need that as well. Simplify will need it. Simplify subsequence will need it. Whenever I call simplify subsequence first, so I'll need that. Item. Well, let's put rules closer to the self. It's more general. Other simplifications are there? do I call the simplification here? And I guess it would be good to first build the whole rule set and then go simplifying it. So that was a bit of boring work.
No, that was kind of useful to sort of see.
Oh, I'm just, adding the argument to everything, and of course I forgot a bunch of places, but I'm not too worried because Python will tell me where I forgot the argument.
Yeah.
And if there's some unused code, well, the test should catch that, right? And of course I don't have tests because this whole thing is meant for exactly one input only.
Oh, I see. Oh, of course.
I wonder if I had a more intelligent IDE, if I could just use a refactor function.
Yeah, PyCharm does stuff like that where it looks for all the interdependencies.
Everything called simplify now gets a new argument.
Yeah.
Yeah, I guess I'm too old to learn. So now every node gets possible start tokens, which needs to be a method because it needs that argument, right? So the whole point of this exercise is to smuggle the whole rule set into here. So now I can put this method on non-terminals. That's probably the most complex one we'll have. So how do I get the set of possible start token for a reference to another rule? I need to get that rule. So rules, and the value of this node is the name of the rule. And well, I get that rule and get its possible start tokens. Right?
Mm-hmm.
And here's a problem. The rule named strings doesn't exist. Where does that appear in the grammar? Strings.
Value.
Oh, there is a strings rule. Now that's a problem. So I go with simplifying the rules in here, and I thought that wait, let me see. So I have a list of rule names to add. I go through all of them. I add it. I convert the grammar node. I add it, and then I go through all the descendants that are non-terminals. Get the rule name and add it here. Oh, and there's this top level rule names.
Oh, maybe there isn't a top level rule for string?
I don't think we have. Oh, right, the top level rules. The top level rules. Right, those are the ones that are documented elsewhere. I see. So I'll need a bigger refactoring of all of this. So instead of generating sections for the documentation one at a time, I'll need to build the whole rule set at once. And then I guess I can simplify that. And then generate the individual sections one by one. But to simplify it, I will need the whole grammar. Does that make sense?
Yeah, because otherwise you might need a top level rule that's in a different place.
Right. So, so this rule set will need to be applied to everything. Where do I call that? I call that
file.
We're here. Excuse me?
Yeah, I was going to say up in there, you don't want to do files with grammar, right? You want to do the full grammar, right?
So parse the grammar here, and then I want to convert the grammar at once. Well, this is probably still useful. Oh, do I actually use the bgen rules just for generating and for debug output? So let's remove the debug output. I don't need that anymore. So here we get the rules. I guess the rules should go in here, and this convert grammar will then generate the rules. So converting the whole grammar. That'll just do all of this. And instead of just rule names to add, we go through everything here. So, name. Go through one by one. I have this already. Make them node, this rule set, I'll need to create that dictionary. And I don't need to go figuring out which descendants to add. I'm adding all of them. Well, that made things nice and easy. But I guess the problem is I should also do the simplification in this function, right?
This. Oh, you mean like simplify grammar?
Yeah.
Simplify. Okay.
So, as convert grammar took care of almost all of this.
Nice.
Except the part where we figure out which rules to document. Right, so we still need rule names to output, to generate. And we we go through the rule names to add. Do we need requested rule names? Later. So this is partial. No, wait. Partial rule set. Well, we need to start with the list of rule names to consider.
Oh, okay.
And we need to generate a list of rule names to generate. Right? So when considering this, we go through the rule names to consider. If the rule name already is in the rule names to generate, then we don't consider it. Otherwise, we go through all of the descendants. So we need the node, which would be rule with the given name, and we go through all of its descendants that are non-terminals. We get the rule name there, and if the rule name is included and is not in tuple-level names, then we consider it, right? So by the end of this rule names to generate, and I guess we need to add that here. This rule names to generate will be our list of rules. Right? So those are the ones we will output. Now here's some simplification, and we should do simplification in the convert grammar part rather than here. So this goes through everything and simplifies each node once the rule set is fully done, so that should be here. Then there's simplifying the rule set repeatedly until simplification no longer changes it. That's fine. And now there's the output. So longest name will be the maximum of rule names to generate. Available space will be 80 minus that, minus this. That's great. Then we go through all the lines, so we have only rule names to generate, so we only have the name here, and we need to get the node. And now we should have everything. Yeah, we should. Ah, that was a big refactoring, so let's
Commit.
yeah. Well, I want to do one thing. I want to disable this again so we don't run into those errors and see what the problem will be. But ask away. Now I don't have access to this variable in convert grammar, so instead of requested rule names, what does the simplify rule set do? It simplifies some rule set using requested rule names, and if we're simplifying the whole rule set, we use the top level rule names here. Right, top level rule names. That should be an argument.
Oh, there was a section on line 680.
Line 680.
Is it requested? Did you need to change that requested rule name?
Yeah,
no?
I guess that's the rule names here.
Yeah.
Which we convert to list.
Okay.
Right. So now convert grammar needs the top level rule names. We call that here. And I think we already have the top level rules. Now the keys of this thing are strings. And what is the problem now? Rule names to generate. Why did I put this append list to a list? This should have been rule name. Okay, so that should have been a refactoring and should not have done any changes, but it looks like we're missing some of the inlining here. Which might be good actually. So the reason we have a diff now is because we consider the whole rule set at once. And as I said before, we only inline the rules that only appear once. But previously it was the rules that only appear once in the snippet we're documenting currently.
Oh,
and right
I see. Now we're looking at the whole
ones that
thing.
are only appear once in the whole grammar. So there's not.
Okay.
So there's fewer of them. So for example, the statements.
Yeah.
Right. So this block was previously all inlined, and now it uses statements, which is just statement plus, and it uses simple statements, which I guess is also referred to somewhere else. Maybe. And I guess Sphinx won't like this because it sees a duplicate token description of name or adder. Right, so yeah, whenever the statements appears, it's documented. Right, so compound statements uses it, and previously it would inline it, but now it's not inlined because this file includes it as well. And I guess we need to pick one place where this would be documented.
Do we look at the rendered docs?
Well, we can't because Things doesn't like this.
Oh, we haven't gotten that far. Okay.
So there's actually not that many of these. There's statements. Actually, I'd rather inline statements, which expands to statement plus, right? So there's nothing that this really brings to the table, just because the expansion is so small. Does that make sense?
Yes. I wrote that down.
Right. So name or
we
adder.
inline things that are smaller. Yeah, we don't. Yeah.
Name or adder is literally
name or adder.
Adder or name.
Or name, yeah.
Right. So maybe it would make sense to do that here. Simplify rule set. There's inlining. So we inline a rule either if its count is 1 or if how do you convert to string? Format. So if the formatted version of well, I guess I need to get it from the rule set, right? The formatted version's length is smaller or equal to the actual name. Let's make it name times 1 point, I don't know, something.
Yeah.
Then we also inline. Alright, so I should probably put it here. Count as 1, or the expansion is small, then we inline. Let's see. And I need to do the length of the name, of course. So how will this work now? Looks much better. So the statement plus is now inlined. That's great. The simple statements are not inlined, which is also, it's probably better this way.
Yeah.
And the name is nice. The positional patterns here got inlined, which is fine.
Yeah.
I mean, the name is bigger than this.
Params did not get inlined.
Which one?
Params, a little bit further down.
Oh yeah, that's right. It didn't. probably documented. It's probably used somewhere.
Okay.
Alright, should we fudge this constant until we get it to inline? No, it's still there for some reason.
Oh.
Oh, maybe it did get inlined, but and there's parameters
I see
here.
param singular, but not plural.
There's
Oh, there we go.
params here.
Yeah.
Huh. Maybe I should use the new rule set here with the simplified thing. No. This is interesting. Why did it not get inlined? Anyway, I see one other problem in this code, which is this top level rule names. So if we're explicitly asked to provide a definition for something, we should never inline it, right? So previously that condition was here, but I need to put it in here as well. So if the name is not in top level rule names, and it's good for inlining, and this comment should probably use rewriting. Okay, so that's one thing we should take care of. It didn't change much. Now this is good. This is good. This param no default. Got inlined, so that's pretty good. Wonder what this params is. Anyway, what changed here? The type param default got inlined, which is nice.
Yeah.
And the star expression, this one, did not.
Oh.
Which, I guess it's fine. What's next? This got simplified quite aggressively. So start expression got inlined, which is nice. Keyword arguments stay, but keyword argument or double start, which is a huge name for this, I guess that got inlined in here. Yeah, it got inlined and then it got simplified even, which is good. This thing got simplified a lot, it seems. It's pretty good. Now here, simple statements did not get inlined, which is fine. For star expressions, we have star expression with this thing didn't get inlined. Maybe it should. Maybe it's documented. Maybe it's referenced somewhere else. Because this is a simplification. That's good. This is fine. Right. So now let's see what Sphinx thinks it's wrong. There's star expression, which now apparently is referenced from more places. Here. And so star expressions reference star expression. And it's also referenced here. So apparently the function definition somewhere in it uses a star expression. And I wonder if it would be good to just always inline this star expression. So
Kind of. I mean, it seems like it's very self-evident.
So
yeah.
One thing we can do, and which we already did for a lot of these, is find a place where this should be defined.
Okay.
Right? So it should probably be defined with these star expressions. Right?
Yeah.
Which is in simple statements RST. So let me go there. So grammar snippet for star expressions should also include star expression, and because I'm mentioning it here explicitly, the generator won't put it anywhere else and will just link to it.
Oh, cool. Okay.
So this makes it a top level name. We've seen a bunch of those, and well, Sphinx moves on to another error. But probably the better way to do this, as I said, would be to always inline it. Let me put that in the to-do. So the next one Sphinx complains about, once it's done building, is simple STMTS, which appear in interactive right here and in statement. So I guess previously it was inlined. Now it's not, because it's referenced from three places actually. But since we have a docs page called simple statements, I guess it should be documented there. So I go to simple statements, and there's probably a statement here, and that should explicitly includes the rule for simple statements. Which, to be honest, this is a much better name.
Yeah.
Well, it's a good name for this mess, right? So
Yeah.
now every other part of the docs will say simple statements, where previously this was inlined. But yeah, it's probably a good thing. And Sphinx no longer complains.
Oh, this is so cool.
We're left with this diff. So block now uses simple statements, which is a link to another page. And previously it was all here, which I mean this change is not all good because previously all the information was available. But I think simple statements is a pretty good name. So overall this is an improvement, I would say. Now class pattern got simplified because positional patterns got replaced with a smaller thing here and here, which is good. Maybe we should change the constant again. Like maybe 1.5 is too much and we should do just a little bit of leeway.
Okay.
Now that gives us this look ahead. I don't know what a good value would be here.
We had 1.3. I thought 1.3 worked okay, except for that one spot that we then fixed.
1.3. I would probably want some kind of configuration to say, you know, this is a good name. I want it kept.
Yeah.
Now we do have T look ahead. Sphinx complaining about T look ahead, which is only used in negative look aheads, but apparently it's used in more places.
Oh.
It's probably best to put it anywhere with the first occurrence here in expressions.rst together with primary. Good. Is that
Oh, nice. Yeah.
Yeah. Okay. So let's continue this. We looked at that. Class. Now I guess positional patterns got inlined, which is good. Function definition. Now we have these params, which is I guess maybe we should inline things that are just another reference. Let's do that later. Let's commit this and do that later. Now we have a smaller thing here. I guess the slash with default is new. I mean overall these changes look good. Type param default is now equals expression, that's nice. Look ahead is defined here. What happened to args? I guess start expression got replaced by this. That's nice. And again start expression. Lambda params got simplified quite a bit. Maybe because of this lambda param to name, which is reasonable. I mean, it's a grammar. And if we wanted this lambda param to actually appear here, we could add it to the input. So we can go back, but I like this a bit better. Now simple statements are explicitly expanded here. We talked about that. Star expression is here. That's fine. Here we got a simplification because of the T look ahead being defined somewhere else. Here there's T look ahead again. I hope to get rid of that entirely once we get to negative look aheads. Import from targets, got this thing inlined, which is great. Interactive, what happened here? Oh, simple statements. So this thing is defined somewhere else. That's pretty good. I mean, interactive, supposed to be short and sweet. And eval got expressions, which I guess could be inline, but it's probably referenced from somewhere else, so it should not. Okay, this is good. I like this change. So what actually changed here is we're doing simplification globally, I would say.
Nice.
Right. And
Yeah.
I said we should do one other thing here. What was that? Oh, when it expands to a single.
Oh, you wanted to put some. Yeah, you wanted to put some
to a
configuration
single
settings, right?
terminal. Right. So if I guess I need this as a variable. No, this is the replacement. Or should I call it replacement or candidate? Here I call it node. Once I know it'll be replaced, I call it replacement. I guess that's fair. So or the node is a non-terminal.
Ah, okay. Right. That's that
Do I
node.
spell it like that? Yeah.
I think you mentioned also at some point having like being able to like literally override stuff or exclude things,
Yeah.
like with configuration values.
Yeah. So that's the to do here.
Mhm.
I can tell this to never inline something by making it top level, which is very useful. And that can be used to mark names that are helpful to the reader. But there's no way to go in the other direction yet. And to be honest, if it's
Okay.
only useful for one thing, it's probably not worth adding.
Right.
So this made exactly one change, and that is to replace params by parameters here, which is good. For a one-line change, that's pretty nice. Or does that do inline? Right. So that was the refactoring for doing the simplification globally. And I guess that's it. And we can now return to removing the lookaheads, which we started and got distracted like an hour ago or so. And of course, if there's anything you want to
Yeah.
comment on, then go ahead. Right, so how far are we? I'm not separating stuff in the commits very well, because I already have this get possible start tokens for the non-terminal, and hopefully that is correct. Another thing I should add it to is choice, right?
Oh,
So if we, I mean, I should add it to all of them, but I'm going in the order Python tells me. So possible start tokens for a choice. Well,
oh.
I start with an empty set, and then I go for each item, and I add, so that's set update with that item's possible start tokens, right? That should be good. Maybe. Oh, I think update takes multiple arguments, so I could do it like this. Does that make sense? I don't think it's clear to
Yeah.
read, but you can do it that way. It's also faster because it doesn't call the function so many times. But we're not going for speed, we're going for clarity here. Now sequence. Sequence, the set of possible start tokens for a sequence is well, I get the first item, and I get, well, I return, or did I forget return? In here I did. Whoops. That would have bit me in the future. So for sequence, I return the first item's possible start tokens. Right?
Okay.
That looks very
Get
easy.
possible start. Okay. Sure.
That looks very easy, but it's not correct.
Oh.
So what can go wrong
If it's an empty list,
here? Right.
then you get a set.
If there are no items in this sequence, then what
The
happens?
set blows up.
I mean,
That is.
yeah. Then we have a problem.
Yeah. Yeah.
Then we have a problem because it's basically possible to skip this sequence altogether. Right?
Can we start with a set that has 0 items? Like the number 0? No, I guess not. Oh.
Yeah, I was thinking about the number 0 or none or something like that.
Okay.
Right? So what we do is we don't have any items, then we return none. A set with none in it, right?
Okay.
Okay, so this means it's possible for this whole thing to be empty. Right? But now...
Yeah. I guess curious. I hadn't seen that notation before.
Yeah.
Oh, okay.
Now the problem here is we just introduced the possibility of this having none in it, which means we need to look at the next item. Does that make sense?
Oh.
So we need to go...
Oh, I see. Right. Okay.
result is an empty set. return the result here, and then we go through the items. Well, self items. We get the possible start tokens from the item. We add them to result. And if we didn't have none there, then
then we proceed. Oh, then we break. Okay.
Right? None.
Oh, I get it. If none
these,
not in. Okay.
Yeah, none being
okay.
in these means we go on.
Right.
Maybe this would be clearer. Right?
Yeah. That is a little bit more clear. Cognitive. Less working memory in the brain.
There's one more thing. If none, if we find an item that doesn't have none, which means it, let's actually name this condition. Item can be empty, right? If the item can be empty, then we continue.
Wow.
Otherwise, we know the item cannot be empty, which means we need to do one more thing, and that is discard the none from the set.
Oh, how cool.
Right? If the item we're on cannot be empty, then the whole sequence cannot be empty either.
Right.
Right? So I hope that is correct.
Yeah.
I should write tests to verify that, but not writing tests for this. And one or more. All right. So one or more possible start tokens for a one or more are the possible start tokens of its only item. I guess there's not much more for that, right? What's next? Token. Okay, the possible start tokens for a token is a set with that token in it. Okay. And we don't need any more, which is interesting. So what did that get us? Atom looks like it got simplified. So this and only this this and only this was removed from the atom rule, which is a good start, I guess. I mean, strings probably can only start with a string or f string start. Let's look at what the grammar has to say about strings. Strings, okay, blah blah blah. So it's either an f string which starts with f string start or a string which starts with string. So yes, this look ahead is definitely not useful. I hoped we would get more than that, but here we are.
Oh, it's still shorter than the original.
question is, why did we not get rid of the look at it here, right? Why did the function def what is actually the start of this function def? Let's see.
Oh, that was that the @, the string called def.
Yeah, this function def. I mean, the function def can either start with
exactly.
this
Decorated.
or the token async or the token def and nothing else. So
yeah.
I would think that this look ahead should be redundant, but it's not. So what will I do? I need to debug this. So that was in sequence, and this simplification. So
is it because it's the first thing? Okay.
If next node is non-terminal and its value is function def, then I want to know more about it. For example, its possible start tokens. Okay, it looks like it didn't even get here, which means we probably end it here. That's interesting. Let's see what the look ahead is. The look ahead is a choice, and its items are not tokens, they're strings. Whoa, 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 whoa. What is going on here? There's a string and there's a token. Oh, I see. What's the difference between token and string? I guess there's not much difference there. Yeah, so I guess tokens in the grammar, a token would be, well, let's look at the rendered grammar. A token would be something like this name, right? But a string would be something like this async or this slash. Does that make sense?
Yeah.
And I think for the purpose of formatting the grammar, we can ignore that distinction. So let's get rid of string, make everything token. Leave token. Ho ho ho. It's gone. So the look ahead we were wanting to remove is gone now. And so is this if in front of if statement.
Ooh.
So is this class or decorator in front of class div. This with async in front of with statement. For async, try, but for try, while, all of them
like
are
magic.
gone. That is magic. That is magic, yeah. I think I can remove my debug print before I forget about that. That worked pretty well. So we also got rid of this opening parentheses in front of tuple group or generator expression, which simplified things very nicely. Opening bracket in front of the listy stuff, this in front of the dicts. That's beautiful. Simple statement. Got rid of this type in front of type alias, return in front of return, import of from, and this is beautiful. If statement, del in front of del. Great, so yeah, a bunch of these are gone now, and we should probably look at other ones. Remove strings. Yeah. Right, that's great. But I don't think we removed all of the look-aheads that should be removed. There's probably some more. What should we do?
You mean like search for the negative look ahead?
Yeah, we should probably look at the whole grammar and see see if it contains any. Can I just quickly dump the whole? I can quickly dump the whole simplified grammar now, can't I? So dump. Dump tree, yeah. Dump tree sounds good. This and see what the output would be. Oh no, dump tree doesn't work.
Oh.
Oh, it yields lines. We need to actually print it out. What I'll do is print out the bool.format as well. So there's a bunch of negative look-aheads. I want to look at the positive ones first. So in lambda parameters helper, we got this positive look ahead, which is great. That's exactly the one we wanted. In T primary, there's a look ahead. There's a look ahead that we might not be able to get rid of easily. Let's leave that one for later. Now for arguments, there's a positive look ahead, which is great. We wanted that one. for lambda keywords, lambda star etc, all this argumenty stuff, have positive look-aheads for colon for lambda, or ending parentheses for actual arguments. With item has a positive look-ahead for stuff after its star target, and that one is probably redundant as well, and that'll be a bit harder to get rid of. What's next? Parameters slash with default, that's parameters. Del, the delete statement, I guess that's the same situation as before. Then there's there's T primary with its T look ahead. Arguments is good. Lambda keywords is good. This is some kind of parameters. With item, we're back to with item. Okay. So, this is the one we should look at next, I think, before going to the negative ones. So let me conditionalize this under debug. Do we have debug? Yeah. Since I found the thing I want to look at, and that thing is here. So with statement means async with, and then we have a big list of with items, which is which looks a bit complicated, but really it's either parenthesized,
Sure.
List of with items with an optional trailing comma, or just with items separated by a comma, and then colon block. And the with item, what that is an expression, and then we have as star target followed by a comma or end parentheses. So this is expecting either a comma or end parentheses to be here.
Okay.
Or we could have a colon.
Colon.
What?
A colon.
What? What is
Yeah.
what is that about?
Yeah. No,
Oh,
I'm just.
oh right. This is all. This is the
confirming.
entire
Yeah,
look-ahead.
agreeing
Right,
with you.
right,
Yeah.
yeah. So, this is probably redundant, but we need to figure out why, right? So with item in here can be followed by either a comma or a parentheses, and the with item here can be followed by either a comma or colon, right?
Yeah.
Now the problem here is if we have this kind of look ahead at the end of a rule, or as the final thing in an optional part of a rule, we need to look at all the places this rule appears at and figure out what it can be followed by. And given that we have 8 minutes until I have to go, it's probably better
No,
to
let's
end with a cliffhanger
yeah.
here and
Yeah.
think about it for a week.
Should we put a to-do or a failing test or something to remind us?
Let me put in a
Yeah.
to-do for next. Just remind me to look at the to-do later.
That's easy. Oh, cool. That's clever trick. Oh, could we put me as a co-author?
Yes, sure.
Do you want me to give you that string?
Yeah. Give me your line. It's probably in the chat already.
It is. Yeah, I'm gonna go
Yeah,
grab
it's
it.
here.
You got it. Thank you.
So it'll be in my fork. If you want to take a stamp, feel free. This will be a bit more complicated, and I guess I need a
Yeah.
fresh brain for that. All right. Thank you for coming. I hope it was interesting and
My
useful.
pleasure. Yeah. Sure.
And see